Hi everyone, I'm Dr. Subbarao from RVIT Institute of Technology. In this video, I'm going to explain fuel cells and the construction, working, cell reactions and applications of hydrogen-oxygen fuel cells. Now, coming to the fuel cells. Fuel cells is an electrochemical device that convert the chemical energy of a fuel and an oxidant directly into electricity through a redox reactions. So the fuel cell is an electrochemical cell that converts the chemical energy into electrical energy through redox reactions. Unlike batteries, fuel cells don't run down or no need to recharging, but rather continuously producing the electricity as long as fuel and an oxidant are supplied. So here if you see the main difference between the batteries and fuel cells. For batteries, we are going to recharge the batteries. If we are continuously using the batteries, they will be discharged, and after discharging they will lose power and they will not use it for further applications. So for that we are again recharge the battery with the external circuit. So we are using the external circuit and recharge it again. Then after they will be undergo charging. So after charging only we can use it multiple times. So here in this fuel cells, these are continuously providing the electrical energy without recharging. So if we supply the fuel and an oxidant continuously, it will continuously producing the electricity. So there is no need of any recharging again. For example, hydrogen oxygen fuel cells and molten carbonate fuel cells and methanol oxygen fuel cells and phosphoric acid fuel cells. These are the various types of fuel cells available in market. If you see, these are the diagrams of fuel cells. So hydrogen fuel cells and other methanol oxygen fuel cells and phosphoric acid fuel cells. Now coming to the first one, hydrogen oxygen fuel cells. A hydrogen oxygen fuel cell is an electrochemical device that converts the chemical energy of hydrogen and oxygen into electrical energy with water as the only byproduct. So due to the combination of hydrogen and oxygen, it produces potable water. So the drinking water will be released during the hydrogen and oxygen fuel cell. So this one is the electrochemical device which convert the chemical energy of hydrogen and oxygen into the electrical energy. It's a clean and efficient energy source. So there are no other harmful byproducts releasing during the chemical reactions. So we are supplying continuously hydrogen and oxygen gases. So this one is a clean and efficient energy source. Now coming to the construction of hydrogen oxygen fuel cells. It typically consists of a anode, cathode and an electrolytic solution. And the separators are used to separate the anode and cathode. The first one is the electrodes. So electrodes means the porous graphite electrodes coated with the platinum catalyst. So here we are using the graphite electrodes. Both are graphite electrodes, anode and cathode. And the anode and cathode were coated with a platinum. And next one is the electrolyte solution. An aqueous solution of alkalines, that means KOH or NaOH are used as electrolytic solutions. And next one is the, at the anode there is a inlet, fuel inlet, which is used to passes the hydrogen gas. So this is the inlet. Inside this one is the fuel inlet. This one is connected to the anode. And here we are circulating the hydrogen gas through the anode electrode. Next one, an oxidant inlet. That means at cathode region, there is one more inlet which is used to supply the oxidant. That means oxygen gas. So the oxygen gas is supplied to the cathode electrode. And here the hydrogen gas is circulated through the anode electrode and the oxygen gas is circulated through the cathode electrode. And a separator. Separator is a porous membrane which permits the flow of hydrogen and oxygen gases. Next, coming to the working. It is having the porous anode. This is the left side is the porous anode. That means it allows the passage of hydrogen gas. So the hydrogen gas is enter into the anode area and it will undergo oxidation reaction. That means hydrogen loses electrons and forms the H plus ions. And the electrons are released and move through the external circuit. And the electrode is made of graphite which is impregnated with platinum. That means the graphite is coated with the platinum or some alloys of palladium or silver or nickel. So they are the alloys will be used for coating of graphite electrodes. And next one, porous cathode. Here the cathode is made with the graphite and which one is coated with the platinum, silver or nickel. And the oxygen gas is enter into the chamber and it combines with the hydrogen ions which are coming from the water as well as anode. And it also made of graphite which is coated with the catalyst. And the oxygen react with the hydrogen ions coming from the electrolyte solution as well as anode. And they convert it into water. This one is the byproduct. The next one is the electrolyte. This electrolyte consists of KOH solution. This one is the aqueous KOH solution which conduct the hydroxide ions. That means OH minus ions which helps in ion transport between the electrodes. So they carry the hydroxide ions and supplies the hydroxide ions to the cathode area. And an external circuit. The electrons travels through the load and they generating the electricity. So this is the working. So I am going to explain simply. Here if you see the anode is the porous carbon material. This absorbs the hydrogen gas. After absorbing the hydrogen gas undergo oxidation. During the oxidation, it releases the electrons. And the released electrons are enter into the connecting wires. And these transmitted through the load from anode to cathode. And the ions will passes through the aqueous electrolytic solution. And they enter into the cathode region. Here, the oxygen gas is passes through the cathode and this cathode will absorb the oxygen gas. And here the oxygen gas undergo reduction and react with the electrolytic solution and converted into hydroxide ions. These hydroxide ions further react with the hydrogen ions. That means H plus ions combines with OH minus ions and converted into water molecules. The water is coming to this cathode region. This is the pure potable water which is used for the drinking purpose. So this is the typical working of the hydrogen oxygen fuel cell. Now coming to the cell reactions. So at anode what is happening here? The hydrogen gas react with the hydroxide ions and converted into water and release the electrons. These electrons enter into the external circuit. And at a cathode area, the oxygen gas react with the water and gain the electrons converted to hydroxide ions. This is the continuous process. The hydroxide ions react with the hydrogen and converted it to water, and the water and electrons are react with the oxygen and converted it to hydroxide ions. So the overall cell reaction is H2 plus half O2 gives rise to H2. So the combination of hydrogen and oxygen produces the water. So this is the overall cell reaction. Now coming to the applications of hydrogen oxygen fuel cells. The first one, applications in transportation. So these fuel cells are widely used in cars, bus, trucks, trains, and even these are used in submarines also. So these are the fuel cell vehicles. So basically cars, bus, trucks, trains. So for transportation, we are using the hydrogen oxygen fuel cells. And these are widely used in aerospace applications. That means NASA uses them to power spacecrafts and providing drinking water. So here the water is used as a byproduct. This one is used in astronauts. Next one, applications in portable power sources. So this hydrogen oxygen fuel cells are widely used in portable electronic devices such as laptops, mobile chargers, and military equipments. And these are used in backup power systems for critical installations, telecom towers, hospitals, and remote locations. Next, applications in stationary power generations. This provides clean electricity for homes, buildings, and industries. So these are suitable for off-grids and distributed power systems. These are the applications in combined heat and power systems. So the waste heat from the fuel cell is reused for heating buildings or water. So this one increases the overall efficiency. So these are the applications of hydrogen oxygen fuel cells. Thanks for watching. If you like this video, please like, share, and subscribe. Please click the bell icon symbol for more informative videos. Thank you.